Law of sines, law of cosines review part 3. Yeah! We're going to be working on problems 12 through 16, essentially the last problems. I'm not gonna lie, I'm a little tired right now, so I 100% apologize if I yawn at any point. This is just the most talking I've done in a very long time, and so my body's like, you need the oxygen. Okay, anyway, moving on. Problem 12, let's do this. Problem 12 tells us that side length A is 17.2, side length C is 12.2, and angle A is 107 degrees. Let's draw this triangle. Sure, something like that. That looks like a triangle. Okay, so let's see. A, B, C, C, A, B. Okay, so let's see. We know angle A is 107 degrees. We know side length A is 17.2. And we know side length C is 12.2. So when I take a look at this, I see this is an example of side-side angle, meaning that we're going to use our law of sines. Now, since this is the ambiguous case, I'm going to take a look at the information we have. I do see that this angle here is greater than 90 degrees. So since this angle is greater than 90 degrees, it must be across from our longest side, which it in fact is. So that means that we are good. I'm gonna write a comment about this. So let's see, A is greater than 90 degrees. And the largest side is across the largest angle. Therefore, this is going to give us a 1 solution. Let's get to solving. Let's solve for angle C first, since I already have some pairs there. So we will say, there we go, that sine of 107 over 17.2 is equal to sine of C over 12.2, cross multiply. Divide both sides by 17.2. That's a 17. And then from here, in order to get C by itself, you have to use sine inverse on both sides. We're going to have sine inverse of all of this stuff. And when you plug that into the calculator, you get C is 42.7 degrees. And then conveniently, it's like, oh, best part. To find angle B, we can say that's 180 minus 107 minus 42.7, and we get that B is 30.3 degrees. Last step, let's solve for side length B. So I'm going to use the same setup that I had before, sine of 107 divided by 17.2, and I'm going to set that equal to sine of 30.3 over B. So let's cross multiply. Divide both sides by sine of 107. And when I plug this into the calculator, I get that B is 9.07. And this is our first problem of this video, number 12. Let's move on to problem number 13. So for problem number 13, let's get this back to black. We know that side A is 11, side B is 10, and angle A is 35 degrees. So let's set this up. So side A is 11, side B is 10, and angle A is 35 degrees. So this is an example of side-side angle, meaning we are going to use the law of sines. And since this is the ambiguous case, I am going to have to check the number of solutions, and specifically because this angle is less than 90 degrees, I'm going to have to check it against the height. So just a reminder, height is whatever your adjacent side is times sine of your angle. Excuse me. So in this case, height is 10 times sine of 35 degrees, and when you plug that into the calculator, you get 5.7. So now we check this to our opposite side, or the side opposite of our angle. Let's see, 11 is greater than 5.7, or A is greater than the height, or that opposite side is greater than the height. These are just three ways of saying the same thing. So now that we know the opposite side is greater than the height, we know this at least creates a triangle. Now we need to compare our opposite side to the adjacent side to see if this makes two triangles. So we know that 11 is greater than 10. We can say that A is greater than B, or that the opposite side is greater than the adjacent side. So since the opposite side is greater than the height, and the opposite side is greater than the adjacent side, this means that there is only one solution to this problem. Luckily for us, that means that we just solve this like we would any other law of sines problems, and we've already practiced a few of those in this review packet. So let's do it to it. First thing I'm going to do is try to find my angle B. So we'll have sine of 35 over 11 is equal to sine of B over 10 cross multiply, divide both sides by 11. And then to get B by itself, you have to use sine inverse on both sides. So you get sine inverse of 10 times sine of 35 over 11. And when you plug that into the calculator, you get 31.4 degrees. 31.4 degrees. From here, it's like, hey, we already know two of our angles. Let's find the third. We can say that C is 180 minus 35 minus 31.4, giving us 113.6 degrees. And last but not least, let's find side length C. So we'll do sine of 35 over 11 is equal to sine of 113.6 over C. Let's take our steps that we need to do. Let's cross multiply. And divide both sides by sine of 35. Excellent. Now we can plug everything into the calculator and say that side length C is 17.57. And there's problem 13. Moving on to our last regular problem. Make sure we got enough of this. There we go. 14. We got side length A is 8. Angle A is 49 degrees. And angle B is 57 degrees. Draw me a triangle. If you can, please always draw a triangle. You'll notice mine are not drawn to scale. That is okay. Let's see, 49 degrees, 57 degrees. So here's a case of angle, angle, side, meaning we will use our law of sines. And since this is not the ambiguous case, we know this is just going to be a one solution problem. Let's do what we can, solve for what we can. First thing, let's solve for that last side length. It's already there. It's easy pickings. So we have C is equal to 180 minus 57 minus 49. And that gives us that C is 74 degrees. Excellent. Now let's solve for our other side lengths. Let's solve for C first, since that's the largest angle. So we'll do sine of 49 over 8 is equal to sine of 74 over C. do what we've been doing, cross multiply. Now divide both sides by sine of 49. Plug this into your calculator. You get 10.19. 10.19. And then for side length B, let's set this up again. And remember, if you have your sides on top of your angles as opposed to your angles over your sides, when doing law of sines, that is okay. This is just how I learned it, so this is how I practice it. Practice makes progress. So we'll do sine of 49 over 8 is equal to sine of 57 over b, and we're just going to follow the same steps we did in green. First, we're going to cross multiply. Then divide both sides by sine of 49, and we get b is 8 times sine of 57 over sine of 49, and that's going to get me an 8.89. Now I said this was the last of our regular problems, quote unquote, that we were going to do, because we do in fact have story problems. Yay, real life story problems. Let's do this. I'm looking at my computer screen right now, and I'm going back and forth between the story problem and the answer key, so sorry if there's like a bit of wait time here. Whenever you're doing a story problem, please remember to draw a picture as well as to write a sentence. So problem 15. A hot air balloon is tethered to the ground by 2 ropes. Okay, ground, 2 ropes, hot air balloon. That looks more like a basketball hoop, whatever. That is okay. So let's see. One rope is 150 feet long. So that's 150. The other one is 100 feet long. The angle between the ropes at their attachment point is 112 degrees. If you'd like a better looking hot air balloon, I think the one on the review answer key is pretty good looking. Okay, how far apart are the points where the ropes are attached to the ground? So it's essentially asking for this C length right here. So from here to here, what is that? That's the only part we need to solve for. We do not need to solve for the whole triangle. So let's solve for just this length. Do that in green. So this will be C squared is equal to 150 squared plus 100 squared minus 2 times 150 times 100. Oh, I'm going to run out of space. Times cosine of 112. Ooh, I just made it. Okay. So it'll be C squared is equal to 22,500 plus 10,000 minus 30,000 times cosine of 112. Combine what you can. And from here, that's as simplified as you can make the right side. So now I'm going to square root both sides. And plug this into my calculator, and I get 209.14. But remember, we're not done yet. It's a story. We gotta put our answer in context. So we can say the ropes are attached 209.14 feet away from each other. And that's what that problem looks like. You'll notice that story problems here are actually going to go pretty quick. And we only have one more in this video and one more for the rest of the review. Let's do it. So for problem number 16, this was a new problem I came up with because you can tell it's about social distancing. Let me read the problem. Let me find it here. So Carmen is sitting in a park and having some social distancing time with her friends. Okay, so this is going to be Carmen. Ivy is 6 feet away from Carmen. So that's Ivy. And Zach is 8 feet away from Carmen. If anyone is wondering how I came up with the names, I've been watching a lot of Carmen Sandiego lately on Netflix. Excellent show, would definitely advise. Okay, you'll also notice in the review, I made a comment about that they're not all sitting in a line because I didn't want you to draw it like that. Please try and draw it like a triangle. So if Carmen reaches out both of her hands to her friends, the angle between them would be 55 degrees. The question is, are Ivy and Zach practicing social distancing by staying more than 6 feet away? So not only do I have to find this length right here, I have to find out if that's more than 6 feet. If they're, 5 feet 11 inches away, they're not practicing good social distancing. So let's check it out. Again, we're going to solve for that side length C. So we are going to do C squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 times cosine of 55. C squared is 36 plus 64 minus 96 cosine of 55. Combine what you can. You get C squared is equal to 100 minus 96 times cosine of 55. That's as simplified as you can make it. So I'm going to square root both sides. And when I plug this all in one go into the calculator, I get 6.7. So since that is greater than 6 feet, it means that Ivy and Zach are practicing good social distancing. So let's write that in a sentence. Ivy and Zach are 6.7 feet apart. So they are practicing good social distancing. And there you have it. So I have the picture, I have the work, I have the sentence at the end. This is what I'm looking for from you. That was the review packet. Test should be very similar, hopefully slightly shorter, hasn't been made yet. Please email me or hop on a Zoom call if you have any questions. Good luck.